Anyway, good afternoon, everyone. Welcome to our session on demand response. As the introduction was there, I am John Rylett. I am the chair of the board for Decentralized Energy Canada. I think we've heard that a couple times today, so I'm very pleased to be here at the event and see you all. I also have a side hustle working for Algonquin Power and Utilities Corp, where I do their sustainability work as well as some technology roadmap and planning, I suppose, is one way to think about it. So it's kind of my day job. And I will introduce our panel here in just a moment because we are going to dig into demand response, but I thought maybe just to level set a little bit. I know we have a number of people in the room here who have been in the energy industry for years and probably know demand response back and forth, but we also have some people who may not, so I thought it would be good to do a quick level set. And to do that, I'm going to say, so demand response at its simplest form, if we go back historically, was really turn that off. About that simple. When we talk demand response, it was typically, or is typically used at a time of peak consumption where perhaps the system is getting a little shaky for some reason, i.e. peak demand, or maybe we have a power plant trip off or something like that. And then the call goes out, hey folks, please turn off things you don't need right now. And we've seen these run. Utilities have done this for decades, actually, if you can go back far enough. You know, air conditioners in Florida 20, maybe even 30 years ago now. Sometimes water heaters have been another popular thing. Moving,
Rotary dial.
True, yes. Old technology. And then up to scale too, right? Up to maybe even the industrial level, whereby when the system got in trouble, the utility could call up some big industrial people and say, hey guys, can you turn off your process or part of it right now if it's interruptible, because otherwise we're going to go black, and that's not a good thing. So old demand response, if that level sets for many of you. We're in a new world now, though, and we've heard about many of these themes already this morning, stuff I've been making notes on, kind of picking up on. But, you know, moving from that, please turn that off, to perhaps please use it differently, or perhaps please turn it on, even, to shape demand a little more. We now have devices and appliances. When I say appliances, I'm referring mostly to things electrical, like battery storage systems as an appliance, as opposed to your dishwasher. But, you know, a battery that can act as a load, or as I'll call it a temporary generator. Of course, it's not making new electrons, but it's releasing them back. And you might want to use that to shape your load. We also have a number of control system improvements where we can actually talk to these appliances and these devices, and we can aggregate them. You know, we saw a couple of examples of that earlier today too, where it was talked about where you can start to get scale, because scale is important as we build this up, right? You want to, ideally, if you're going to do these things, you want to move megawatts and megawatt hours, not, you know, kilowatts and kilowatt hours, if you can get to that level. So with that start as a level set, when we're going to talk demand response, it's sort of coming from the world of turn things off at peak to avoid going beyond your limits, moving into a world of, well, maybe we want things to turn on at certain times because we have, say, excess renewable energy and it's cheap during the day, or perhaps we can just use them better to manage. I think we're going to hear, Sarah's nodding, so good. Okay, we talked about this at lunch. I think she has some good stories. So we're going to get into that. And of course, the big part of this is, if you're going to do these things, how do you put a value on it? Who's it valuable for? Who's going to pay for it? How does that all work? And so I have a panel. Actually, this is really good because I think we have this great spectrum up at the front of the room today. And so maybe I'm going to start at that end with Keith Cleland, who is the CEO of Aquacell Energy. And I'm starting at that end just because Keith is a new technology innovator. He's got a startup. They're working on it in the storage space. He'll tell you more in a moment. I'm going to skip. I'm going to come down to this end for a moment. I'm going to come to Brent Harris. So Brent, founder and I think COO of Iguana Technologies right now. Basically distributed battery storage energy management systems and moving up the chain there, but with a mature product in various markets and continuing to grow. So we're kind of moving along from the startup to the new tech to an established tech to building market. And last but not least, Sarah Mudge, who is the senior technical lead with New Brunswick Power, or NB Power, who has run a number of pilot programs to implement things, the kinds of technologies that both Keith and Brent have, are getting into market or want to get into market, and is dealing with it from the other end. I'm going to say the utility end. And of course, all three of them have to deal with their respective customers in this mix. So it's sort of an ever-evolving, innovative, and complicated market. But now I introduced Sarah last, but maybe I'll let you go first, and maybe could you give us just an introduction to your role and how demand response fits into your day job at NB Power?
So can you hear me? There we go. I can hear me, so that means you must be able to hear me too. So Sarah Mudge, Senior Technical Lead at NB Power, and I play very much on the customer side of the utility. So not the Senior Technical Lead in nuclear transmission or distribution assets. I'm definitely more on the behind the meter. So solar panels, batteries, smart thermostats, heat pumps, all of those fun things. So you're going to probably hear me say a bunch of things that sound really weird and foreign because New Brunswick is kind of an anomaly compared to the rest of Canada. So we are the most electrified province in the country. 80% of homes and businesses in New Brunswick are already heated with electricity and have been so since the 70s. Everyone else faced an oil crisis in the 70s and invested in natural gas. We invested in nuclear power and converted all the homes to electricity. And since the 80s, every home that has been built in New Brunswick has been built with a 200 amp electrical entrance. 2 out of every 3 homes in New Brunswick has a heat pump, and we expect that to be at 100% within the next couple of years. So very different market in New Brunswick, and what that means for us, since everyone is heating with electricity, is we are known as a winter peaking utility. So most utilities in Canada face an issue associated with air conditioning loads being, summer peaking. We are a winter peaking utility. Our demand doubles in December and March and triples in January and February. The colder it is outside, the more demand there is for electricity. And we actually peak in the wee hours of the beginning of the morning before the sun is up, when wind is dying down. So for us, if someone here can figure out how to harness the power of cold and darkness, when it's minus 25 and dark out between 6 and 9 in the morning, I'd love to hear from you. So there's a great little pitch idea for next year, maybe, if somebody can come up with a solution. So we're really looking to figure out how do we reduce that demand on the grid in the morning. And we've been doing some major research projects over the last few years, and a shocking but fun finding that we came to was that our peak demand in the morning is caused by homeowners who turn their thermostats down before they go to bed at night. So we now have to, as a utility, go out and re-educate a society that we've been paying to buy smart thermostats for the last 30 years to stop buying smart thermostats and stop turning your thermostats down before you go to bed at night. And if we can get them to do that, we can actually reduce demand by 30%. Something as simple as how you choose to interact with your thermostat can reduce demand by as much as 30% for your utility. So that relationship between customers and energy behavior is really the crux for us in this energy future. Yes, technology is a big part of it, but it has to be technology that is easy to use, intuitive, and not ask people to compromise on their comfort, their convenience, or their safety.
Sort of a very surprising finding. To my mind. Again, I grew up in the old world. Nope, turn down night, turn up in the morning.
We all did.
there we are. But it starts to make sense when you start to look at the system and the heat pump technology and other things that I know you guys have in. I think you claim to be the heat pump leader in Canada.
We are the heat pump capital of Canada. That is the Sarah Mudge self-professed. 2 out of every 3 homes. There's no one else. I even checked with Quebec because they're number 2.
There you go. You heard it here first. Okay. So maybe I'm going to jump down to the end there to Keith. And so Keith, now you're at the other end of the spectrum. You've got a new technology coming. So let's hear about Aquacell Energy, where you guys are coming from and where you hope to get to.
Yeah, absolutely. So it's funny where I started. Actually, I think I'm probably the only one on this panel who had started out in the wastewater treatment industry and is now talking about renewable energy. But that's a very important part of our journey. So at Aquacell Energy, we are building giant batteries made of water and salt. Now, the advantage of using salt water to power these flow batteries is you can get very long duration energy storage, 12, 24, up to days worth of energy storage, using one of the most abundant resources on the planet. It also is much safer and sustainable. You don't run into the supply chain issues with lithium batteries. And the hardware that houses the water and salt is actually mass produced in the water treatment industry, hence my humble beginnings. So that has allowed us to become one of the fastest growing flow battery companies in the world because this technology, it's already mass produced in this industry. For reference, like a battery about this big in the lab scale, going from that to a battery as tall as me at the kilowatt scale, we got there in just 6 months, where other competing flow battery companies would have to take years to get there and spend tens of millions of dollars to build the factories to get there. So now we're at a point where we've got a factory, we've got a manufacturing partner, we're fundraising so that we can put a dozen of these battery stacks into a shipping container, becomes our full-scale pilot at, say, 25 kilowatts. We want to get a demonstration unit up and running for the distribution utilities to help out with the demand response issues. So we're looking at piloting Alberta. I see some familiar faces in the room. The way we can help these utilities out is, the way I think about it, it's both an issue with supply and demand of electricity. So when everybody is demanding electricity all at the same time, that's when you start to run into issues on the distribution grid. It's peaked out, you have the substations you're gonna need to upgrade to handle all of that excess capacity, but it's only at that maximum. Where the batteries can help is during those peak hours, you can actually power the grid, power the grid using these batteries, take the load off that excess demand, and then charge it up when nobody's using electricity or from renewable sources. Now, for reference, it's about $40 million, or in that ballpark, to build a substation, but about $5 million worth of batteries can actually defer, or in some cases avoid the need to install that substation. So this is where the demand response of the battery can help with the demand on the grid. Now, on the supply side of things, you can get very wild fluctuations in electricity prices. So, solar energy, when it's pumping onto the grid, you can get next to free electricity or even $30 a megawatt hour. But when there's no solar, no wind, and you're ramping up natural gas, it can be into the thousands of dollars per megawatt hour. So the batteries, once you've installed that battery for demand response, you can then start to use it for these other revenue streams, buying and selling electricity, or just even avoiding the cost of expensive electricity. So that's what we're focused on at Aquacell Energy. And then, even if they do make an upgrade on that substation, you can move these batteries to a new strategic location. Likely, the utilities would be deploying these on customer sites who are heavy electricity users on the grid, so that they can participate in these demand response programs. So I could talk about this forever, but that's the whole point of this panel. So I'm going to leave it there.
Okay, well, thank you, Keith. Actually, great start. And I think maybe, just to touch on a few things there, I heard infrastructure deferral. I heard improve, I'm going to say, capacity use of infrastructure in there. I also heard, perhaps improve value of energy, i.e. don't either dump it or curtail it when it's cheap. You have somewhere to put it. So 3 different value propositions. I've probably missed one even.
There's lots.
There's more there. But let's go to Brent. And Brent Agana Technologies, and we talked getting ready for this, and actually it sounds like some interesting Canadian things, because I know you have actually had much more success. We heard this earlier, about Canada versus other places. I know you guys have been much more successful outside of Canada. Historically, but it sounds like maybe it's coming home. But I'll let you do the introduction.
That's right. Brent Harris with Iguana Technologies. So we manufacture residential energy storage systems and aggregate them together to deliver services to utilities, a lot like what Keith was talking about there. And yes, we've been around for a while. We actually started the company over 20 years ago to create VPPs in Germany. And it's been a long, winding path. We've had that target in mind and found other applications to advance and commercialize, improve the technology that we have. And seems like the market's caught up now with virtual power plants coming on and demand response. So we sell our products, have traditionally to consumers directly. We're selling under the Duracell brand in the US market right now. As Iguana, we're focused on utility business, so selling directly to distribution utilities to help them support and get better utilization out of their infrastructure, and also support demand response programs. So we're doing targeted consumer sales in areas where there are stalled demand response programs. We can talk about that a little bit today, what's happening with those programs where they're not finding any batteries to enroll into these programs, and so we're helping them solve that problem. As far as Canada, yes, we've started out serving markets in Germany, Japan, the US, Australia. With net metering in Canada, there's not much of a battery market for consumers when the grid is just a big free battery that you can use anytime you want. It takes away that value proposition, so you're just left with the backup power in Canada. But just as we've seen this shift happen globally, it's been really rewarding for me personally to see a lot of opportunity come up here in Canada with utilities on the East Coast and the West Coast, and trying to get something going in Alberta too.
It would be nice to do something in the home province, right? Is that, yeah.
That's right.
So you have to leave home to be successful, I think. Is that?
That's right. It's actually, to go into the innovation side, I've chewed a lot of glass along the way. And there's a perception out there that you need to be successful at home and then take it elsewhere. That's certainly an easier path. Having a market out your back door lets everybody in the company participate, not just the people that get the flights out there. The salespeople get to see the customers and nobody else. So it's helpful, but it's not the only way to do it, and I would say it's one of the challenges with the innovation programs in Canada. Don't recognize that Canada is a small market next to a massive market, and it's not the worst thing in the world to go cut your teeth there.
Yeah, well, maybe, to the panel who was up here earlier on innovation, there's another a point. I don't know, you didn't throw your hand up earlier, Brent. Maybe you should have.
There wasn't all that many opportunities to throw your hand up.
Okay, fair enough. So maybe actually, to dig into this a little more, maybe I'll just throw a question back at you. Those different markets, because you've experimented with several now. With your product, is it all the same value proposition, or is each market got a slightly different one? Like, are you able to go into Germany or Hawaii or Canada and pitch this sort of the same story, or is it different to the end user in each one of those?
It's different in each one. The technology is very similar. There's some nuances on the certification side that change market to market, but what can you do with a battery? You can charge it and you can discharge it. And you can create some reactive power, but that's about it. But there's so many different ways to create value out of that. When we started in Germany, only half the systems in the market even had a backup power feature. It was all about cost savings with the falling feed-in tariff on solar. In Hawaii, it's a mandate. Can't get solar without putting in a battery alongside it, and the battery needs to be programmed XYZ to keep that peak off the grid. Australia is probably the most interesting because the market operator there has decided to include distributed generation in their integrated system planning. So as elsewhere they say, yeah, we'll tolerate this, but as we make our plans for the future, we're not going to depend on this distributed generation, but they do in Australia. They have a forecast for what's going to be there, and they say, yeah, we're not going to build that other power plant because we have all this distributed solar. So that's pretty innovative.
Really interesting. Actually, I think we're going to come back to that point as well. But I think I also heard there. What I heard was sort of a end-use customer going, "This is better for cost savings," right? Or Germany, the original one. Grid issues in that I can't put up solar unless I have a battery. So the Hawaii example. So this is me looking after myself a little more in that case. Australia is a third case. So Sarah, I'm going to come to you. Did Brent just mention in any of those three? what is New Brunswick Power interested in? All three, or one of those in particular, or where are you coming from in that space?
Well, definitely all three. And I mean, our biggest challenge is the fact that electricity has pretty much been socialized in New Brunswick, and NB Power operates as a non-for-profit. So we are owned by the citizens of New Brunswick, and the return on investment that we give to our shareholders is low and stable rates. It also means that a lot of our cost for investing in infrastructure upgrades, new generation, is largely deferred into the future. So we have a 90% debt to asset ratio right now, yeah. So we actually don't own anything. We're still paying for it. And under a not-for-profit business model, we can only pay down our debt if we have excess revenue. Climate change has been kicking our business model's butt, right? So every year for the last decade, there's been a hurricane, a flood, a freak ice storm that has produced unexpected costs that has eroded our ability to pay down our debt and keep electricity low and stable, which is that ROI we're supposed to give. So looking for ways to get electricity where it needs to go to minimize making those big purchases, because we have such a bad debt to asset ratio, is very important to us. So if we're seeing load growth, whether it's population, whether it's just seeing more electrification of transportation. So electrification, transportation, and industrial electrification are our two big load growth areas, because we're there on the heating side of things. So that ability to defer, needing to build more power plants, and giving our customers the ability to better manage their energy. And resiliency is important. 25% of New Brunswickers own their own backup generators, so we know that they're there willing to make those investments. And that's why we're talking to partners like Brent and Iguana on, hey, is there a product or service that we can bring to our customers? We know they like resiliency. We know that most homeowners in New Brunswick are heating with electricity, so maybe a battery is a better fit than a propane or diesel-fired generator for their backup power.
Okay, so it's good. We have some overlap. I think that sounds like a good start. I'm going to come down to Keith down there at the end. You're working on your new product. What you just heard here, does that align with where you see your technology going into that demand response world? Challenges, hurdles, where do you think?
Yeah, absolutely. I think I agree with a lot of the common threads there. Like the demand response is at a core is going to be similar around the globe. It's just how do different markets incentivize that, right? So if you're looking at just deferral of infrastructure, for example, almost every distribution utility is going to run into this sooner than later, especially as we're getting all electric vehicles, electrifying everything. So that's a common theme there. But then it's like, how do you incentivize that? Like, so I've seen a couple different examples in different markets where California, New York, they've just come out and said, we're gonna procure, I forget how many gigawatts of long duration batteries because we know this is an issue. And that really is important for the battery industry because it gives you price certainty, revenue certainty, that that like there's a firm business case here, and that's probably the best one, where it's like, okay, buy the battery outright, we know it's going to help defer our infrastructure. But then, absent of that, there's also a lot of market mechanisms, a lot of different revenue streams that you can get on top of that, where, how do you arbitrage that electricity? How can you manage local demands or demand response programs? The key here, though, is like some of those, like energy arbitrage, it's, it's not always a guaranteed revenue stream. Like that could change next year, and then how do you get financing for that project? But if there's a more guaranteed streams of revenue that you can show with this, that's going to be really important for getting these demand response programs, and making sure it's like in alignment with the value. Like if you can avoid a $40 million investment, then the size of the revenues or the procurements should be, maybe you're not trying to spend $40 million, but what's that in between number that's like, okay, you're doing nothing, not nothing today, but like what's that in between that you can still incentivize what you need? So thank you for the answer there. I think that's great insight. I guess one of the key questions I would have in that space then, like the concept of deferring the infrastructure, right? In essence, is this a less expensive way to provide the service, the utility that the customer either wants or needs?
That depends on the utility.
Okay, this is what I want to get into a little bit, just in my own personal experience in this. I've often found it difficult to find that business case, to truly put it out there, and then, perhaps have business as usual accept it and or a regulator accept it. So I guess I'd be curious if any of you want to maybe tackle that, just some insight into, like, does the infrastructure deferral argument work? Or when does it work, or when doesn't it work? I think that would be some great insight if you had, whoever wants to, or all of you can hop in. Brent, if you want to go.
I just jump in on that. I think there's some concern about whether the capacity delivered that way is going to be available the same way a chunk of copper is available. But it's being trialed. So we have actually an interesting project just getting ready to announce here in BC, where we're delivering storage systems that are part of the what is it called? Anyway, the demand response program here in BC, and BC Hydro is procuring those batteries and putting them in specific homes that are on feeders that have constraints. There's load growth at the end of the feeder, and they're not able to support it without significant infrastructure upgrade.
Okay, so this is BC Hydro basically has said, hey, it is less expensive and quicker for us to do this strategically
Yeah,
than it is to reconductor or upgrade.
right. And they're going to
Okay.
get the demand response value from the Peak Saver program, whatever we called it.
Peak Saver, good.
The Peak Saver program is a system-wide benefit, so anybody can participate in the province. But if they put these batteries on these specific feeders, they can also control them to manage the peak load on those feeders preferentially. So it gives them stacked value there, and then the homeowners, who I understand are also experiencing some reliability issues on those feeders, are also going to get some resiliency out of it. So you kind of get three benefits. So it's not a pure test of infrastructure deferral, but it's been made part of this program.
Okay. But I guess the stacking is quite interesting, but the fact that it does also seem to be justified heavily on the, okay, we can avoid stringing more copper, right, or something
That's right.
equivalent. Yeah, interesting. Okay, Sarah, I see you nodding. Comment on.
Yeah, I mean, so from the utility perspective, in New Brunswick context, 12 cents a kilowatt hour is our current price of electricity. And, Canada has the third lowest electricity rates in the world. And so often we hear about the markets that are the most aggressive with things like solar and storage. They're often in a 25 cents or higher per kilowatt hour, which is just unfortunate because we pilot the heck out of things, and I'm going to say thank you very much to the federal government for giving us money to do that, because I can always build a business case to spend someone else's money. We have not been able to build the business case to make those investments with ratepayer funding against 12 cents a kilowatt hour. So that's still that hardest part.
Can I just dig in it? So, yeah, 12 cents, I wouldn't think so. But is there the forward-looking, like, can
Exactly.
we defer? Like, sort of coming back to your earlier point of the, we're not-for-profit sort of crown corporation. If we can defer this,
Yeah, and that's what we do. And as a utility, every 3 years, we have to file what's called an integrated resources plan. And that's where we're basically asked, if you had to lock in today on how you will generate electricity for the next 25 years, what would you do? And we have to show that it's going to be safe, reliable, lowest cost electricity options for New Brunswickers. And we update that plan every 3 years. And I remember one of our vice presidents said that the IRP is out of date as soon as it is published. Like from the moment it is published, it is now obsolete because something has changed since we printed that sucker, right? So the world is always changing, and that's why we're almost saying, if we had enough time and resources, we'd probably update it on an annual basis. But if you read through our IRP, one of the things that you'll notice is demand-side management is actually a significant, and investing in demand-side management to defer the need to build more power plants, but also to reduce demand. So energy efficiency, we're spending $160 million this year on energy efficiency retrofits for homes and businesses in New Brunswick, because reducing demand is just as important to electrification so that we can avoid having to build more power plants to support transportation, to support electrification in industry. I'm actually not as worried about the electrification of industry. I think most of them are going to become prosumers. And we're seeing that with some
they'll invest for themselves.
Exactly.
So you guys.
Yeah.
have a role, but maybe less of one.
Yeah.
Is what you're saying there.
So
Okay.
population growth is probably, and transportation are probably our two largest areas. So the only way that we're going to be able to get there, keeping in mind that 100% of our generation assets are expected to reach end of life by 2041. So we're not far out from everything needing to be replaced. So helping people to manage their energy, whether it's at the home, at the business, at the feeder, or at the substation, is a big part of our long-term investment play.
Maybe just to dig into it, you said 160 million. How much is that? Like, there's energy efficiency in there, demand side management. Is there
That's 160 million is energy efficiency only.
energy efficiency? Okay, and is
Yeah.
some of that truly demand response where you can vary it as well, or are all those programs are just let's get you to be
We would have a
better
separate
user?
budget for demand response.
So it's separate
Yeah.
even on top of that. Okay.
Yeah, so
great.
reducing demand just through energy efficiency upgrades. So that could be adding insulation to a home. It could be putting in a cold climate heat pump instead of your regular heat pump. It could be adding just energy monitoring to a commercial building that wasn't there before. So
Okay,
they can,
number of things. Okay, great. I want to come to the end to Keith on this. You've just heard a couple things about and you talked about it. You said you're the guy who actually threw out a number, the cost of a substation. If there's engineers in the room who've built a substation, you can test them later and see. But the number holds from my experience, or relatively. I guess I'm curious, when you're hearing this and you think about your product, conversations you've had, where do you see fitting into that? Is that, or maybe a different way to ask it is are you going after that infrastructure deferral? Do you see that as your core value prop with your technology in the demand response world?
Yeah. I think that's something we see as a core value that we can bring. That's the biggest reason for utility to say, okay, this is an expensive problem. It's very, urgent with electrification needs coming up. But I do want to double down on the whole stacking of revenues, because there's so much more that a battery can do, and especially with us, we're longer duration than a lithium battery. We could do 12 or 24 hours of energy storage. So for this application of infrastructure deferrals, you might only need that battery to be running for 4 hours. As demand grows, that peak gets wider and wider. So, in the future, maybe it's 6, 8 hours. If we have a 24-hour battery on site, there's so many more things that you can do with that battery, and a lot of different revenue streams that you can generate. So it kind of sweetens the deal for this infrastructure deferral, because now it's not just poles and wires, a substation that you're installing on your grid. It's a revenue generating asset. Now, there's also that argument about, okay, there's the regulatory side, the utilities, distribution utilities can't always buy and sell electricity, but they could contract it out to a third party. For example, that's something we're exploring as a role that we could do with Aquacell. Contract out that battery when it's not being used for infrastructure deferral. We can guarantee that it's always going to be available when you need it, but during those other hours, 90% of the time, you could be doing arbitrage on electricity. If it's co-located on a customer site, you can reduce their local demand charges. That site would get the resiliency benefits of the battery as well. So there's a lot of different ancillary services market. I could go on about it, and it is market dependent, but I think having that stacking really, let's say, amplifies the value you can get out of using energy storage for demand response, but what else can you use it for?
So maybe that actually is a great segue, I think a great answer, and a great segue to my sort of next question, maybe just to throw to each of you, who do you think should own these things, if you will, in terms of, or be in command of the demand response? Does it sit best with the utility to do it? Should third-party providers, hybrid? I'd be just curious to know, what you've maybe seen that you thought worked best. I could start. Keith, you kind of mentioned you talked about a whole stacking thing. Now, that kind of sounds to me like you're going to own this thing and sell different services to different people. Maybe the utility gets some demand response, the market gets some energy arbitrage, or a customer does, or something like that. Do you have a preference?
So actually, the way, and this is something we're exploring a business model as we scale up, but what we're envisioning is the utility would own the battery. They're the ones who it's most critical to solve this problem of demand response. So they would have they could own the battery, have first rights to using it. But then you can contract out those services to a third-party provider. So that's that's where we see, like, because they have this urgent need with a substation, they probably want to be in control of that battery and maintain that ownership. But then, you can enable the end users you deploy it on site with. They can get all the benefits, or the third-party provider who's doing those services. But that's what we're envisioning, but learning as we go.
Yeah, so I'll come into the middle, Sarah. So do you want to own it, or will you share it?
We have no money, so we can't afford to buy it.
Okay. That's
so
you have the same issue that most of us have when it comes down to these
Yeah,
things,
exactly.
right? Yeah,
And so
okay.
this is where there are really great opportunities for energy services company, right, who basically would own the asset and would get paid for providing it as a service. So let's say, we'll pick on a battery. If I give you a battery that helps you to reduce your demand by $500 a month, then you pay me $200 of that $500 a month, and that's how I get my money back. So customer opportunities for us, like batteries, a really great example for us. We're working with the City of Moncton now, the fastest growing city in Canada right now at the moment. And they are in the process of converting. They have 37 public transit buses that are being converted over to electricity. And that is going to significantly increase their demand at their transpo facility. But they want a guarantee that those buses are all going to come off the runs at 11 o'clock at night. They're going to be fully charged and ready to go back on the road at 6 a.m. Otherwise, they can't provide a reliable transit service. So they need massive batteries, purely from a resiliency perspective. There's not much of a business case there for the utility. But as long as the power doesn't go out overnight and that battery is fully charged, if our grid peak is from 7 to 9 in the morning, all those buses are now on the road. They're not even hooked to that battery. So there's a business case for us to potentially co-own it so that we could then dispatch it after the buses are done, charging overnight.
Interesting. Very interesting.
So this is, I think it's going to depend on the utility, who's got the money. Are they for-profit utilities or not-for-profit utilities like we have in New Brunswick?
True. I mean, the market structure and ownership, of course, probably any, you could make a long list and still not have them all on it, given how sort of a hodgepodge the electrical system is around the world, really. Brent, your thoughts? I mean, I think you've sold them, you've owned them. You would rather just sell the services? Where are you guys at?
I think what makes the most sense, so we talk about the stacked value, there's usually one of those that has the most value in every application you just mentioned with the buses. Whoever's getting the primary value out of it is the natural owner. We're caught in a bit of a trap with these virtual power plants and demand response programs that were built up first with thermostats and then electric vehicle charging. That's the customer's thermostat. They bought it because they want to see what's happening at home when they're on vacation, or they want to change the temperature when they're laying in bed, whatever it is. They bought that thermostat. Now you can ask them, hey, can I use it once in a while? Same with the electric vehicle. They bought it because they wanted to drive an electric vehicle. Now you can talk to them about exactly when they charge it. What's happening with the batteries is it's kind of the next evolution of these programs. And they go out and look there, like how many thermostats are in our service territory? Oh, there's 200,000. Well, let's try and get 10% of them. They can't do that with batteries because there's just not very many out there. There's a few Teslas out there, and Tesla has their own business plan about what they're going to do with those batteries. But we think in the long term it really makes more sense either for an aggregator if the focus is on demand response, or for the distribution utility if the focus is on the infrastructure investment. And I guess around that, I just wanted to throw one other point out there. It's when you're looking at upgrading a feeder or a substation, you're not looking at solving the next 5 or 10 years of problem. When you make that investment, you're looking ahead 50 years, and there's a big step. And if you can avoid that step, I mean, there's an economics to it, but being able to do it incrementally has a lot of option value, unless you kick the can to that next integrated resource plan without making the big investment.
Even to complicate that a little bit, I watched a session on the new investment tax credit and the ownership models of that, and they were talking about setting up joint entities. So each project, you set up a new entity that is eligible for the investment tax credit, and maybe there's some innovation there about who gets the most value out of this project is maybe represented in the ownership structure of that entity.
True, a whole other layer when you start to add in, various tax credits and things that may or may not incent and rules, well beyond the technical capability or the the business of providing energy. Now you've got a third piece in that. But maybe this is a good way to segue next into this piece around, and we touched on it. I think Brent, you mentioned it earlier, but it's that resiliency and reliability piece. And I know this is a knock on this demand response in some places, or the the concept of the virtual power plant is like, oh well, how do we know it's going to show up? You go to your regulator and you say, well, I'm not going to upgrade this line or this substation. We're going to do this instead. And the regulator says, like, how do you know it's going to work? Are you confident? Is it utility grade? Or is that like, sort of commercial or commercial grade product instead? So I guess I'd like to get some thoughts. Brent, you've kind of worked out there. We got the utility. Keith, you're developing a product. You got to know what you got to hit, what bar you got to jump over. So I don't know, Brent, starting with you, just thoughts on that.
I think if the ownership is with the utility, they're going to have a lot more control over how the battery is used and a lot more ability to ensure it's going to be there for what is needed. I think the concern with a lot of the demand response programs is the opt-out process, and when the consumer owns it, they always have the right to say no. You're not. I need
day 3 of the heat wave. I'm tired of my air conditioner being turned down or whatever. I'm out.
Yeah, and I
that
think
kind of thing. Yeah,
the reason you want to use it is because you're close to the edge, and if the whole thing goes down, I want some energy in my battery, and that tends to be how people think about it when they've made that kind of investment in a battery. I thought the presentation from Australia from, I think it was Sophie Allen this morning, was quite interesting, where I took a few minutes and read her paper actually just at one of the breaks, but something changes in people's perception after they buy a battery, and that becomes theirs, and that's their resiliency. And if you go talk to them about demand response or a virtual power plant, afterward, it's a very different customer you're talking to than someone who's not sure if they want to buy a battery yet or not. And you want to bring it up first and build, whether you incentivize it heavily or build it into the contract and get it on board from the beginning as a grid asset.
I could see that. Is it very true, right? Once you have it and it's sort of yours, well, hang on, the value. Actually, Sarah and I had this chat at lunch too. We were talking about car batteries actually, but I was saying, well, yeah, you might fill it for $5 worth of energy, but like, I'm not going to let you drain my car for $5. I want 50, right? Like it's a different value prop that comes, and I think something that needs to be considered. Sarah, sort of the same kind of question on the reliability. Does it show up or not? I might even throw to you, just because you are the utility person, a little pet theory I have. If you have thousands of devices, and we're kind of using the Internet of Things, we're talking back and forth and stuff. So this is, in essence, not your typical utility grade. We do not have SCADA running to everyone's house. We don't have the kind of hardened infrastructure. But we've got 30,000 of these things. So if a couple hundred disappear on an average day, is it a big deal? Is it a big deal, I guess, is part of my question.
Well, and I guess that it depends on how you're building your business case, right? And something that people will say things like, we own 90% of the water heaters in New Brunswick. So it's a natural fit for us to say, maybe we should be trying to control some of those water heaters and turn them on and off. You cannot turn something off that is not on, right? So we have no control over when someone's water heater is in use and when it's not. So I can't say...
You can't tell them to shower between
exactly,
the hours
yeah.
of? Oh, okay.
We can influence that through rates, right? And we can say, we're going to reduce your water heater rental by $2 a month if you let us turn it off after you're done showering. So the thing about storage water heaters versus instantaneous is reheating water in a tank always happens after it's been used. So nobody cares if the water in the tank is cold after they're done showering. So that's kind of what we're looking at, is instead of that water heater turning on during our peak, when people get up in the morning and they crank up their thermostat and then they hop in the shower, right? We're just going to defer when that water heater reheats. So people are open to that. We're going to reduce your rental cost if you let us not reheat your water until, say, 10 a.m.
Tank.
Go ahead. One tank.
Get in line.
Exactly, yeah. But on the battery side of things, what's interesting for us is the way that it's regulated. We can't stack value. We can if we own it. But so as an example, if we were to say, okay, we're going to invest in batteries to provide ancillary services, a battery cannot charge and discharge at the same time. So if we said in our IRP, we're going to invest in battery technology for ancillary, their expectation is it's always going to be sitting there 100% charged in case there's an emergency. We could not say we're going to get additional value from that battery because we're also going to do this other thing. Because as soon as we do that other thing, it's no longer available for ancillary.
It's not available for the primary use case, yeah.
Right. And so this is where if the customer owns it and we pay them to let us play with them, right, that's where there's a different technology. So, or a different relationship on the technology. So it could be that we have a demand response program that we pay you every time you participate. It could be that you're automatically enrolled in this demand response program in exchange for 30% off the cost of your battery or your smart thermostat or whatever it is. So it depends on what the customer values, right? So if they value resiliency, they don't ever want us to deplete that battery. Right? So just go away, don't touch my battery. To your point, it's mine, leave it alone. But there's a price point for a lot of people that, okay, I'd let you deplete my battery by 50% if you were going to give me $100. So then the question is there $100 worth of value to the utility if the customer won't play with you unless you're willing to give them $100?
The true value question, what's it worth to you versus what's it worth to them, and the social part of it.
And that's our biggest challenge and has been for the last decade. We've played with electric thermal storage, we played with water heaters, we played with thermostats, we played with solar and battery. We cannot crack that budget problem, return on investment at 12 cents.
It's very difficult at 12 cents a kilowatt hour.
But every time we apply for a rate increase, we get a better ROI on that investment. So we're waiting.
So if you just drive the prices way up, then you'll have lots of opportunity.
Right now we're waiting on a decision. Are we going from 12 to 13 cents this month is what we're waiting to hear. But it sounds silly, but going from 12 to 13 cents just brought us about being able to give someone $10 more that month for participating in that demand response program. So
every penny counts. Remember that. Keith, just to come back to that reliability piece a little bit, as you're getting your technology ready. Do you know what bar you need to jump over? Do you have a sense of it? Where are you there?
Yeah, so it's interesting. I mean, when I think about reliability for demand response in general, it almost seems like it feels like the opposite, right? Like the utility wants you to turn everything off. We'll pay you, but turn everything off. That doesn't feel like reliability. So I think it's really about equipping those end users with tools that can do demand response. In our case, long duration battery. The demand response program will add reliability to the grid in the sense that if enough people are participating, then the grid doesn't have to do this thing called a rolling blackout that they, on a cold day in Alberta at January 4th and it's minus 40 out. Nobody wants to hear that. It has these secondary benefits of resiliency because once you deploy these batteries on the end user site, when the utility is using it, it's contributing to the resiliency of the grid. But in our case, I'm biased towards the long duration battery because now, for those other 16 hours that the battery's not being used, the customer can benefit from that resiliency of having backup power. If there's an unplanned outage, for example, they can now lean on this battery for, okay, the grid's down, but we're still up and running because we agreed to host this battery. And then, the other thing I like to think about is just this short versus long duration energy storage. Like most lithium batteries are 2 to 4 hours right now, but if you're getting longer and longer peaks on the grid, if you're going from a 4-hour peak to an 8-hour peak, all of a sudden your batteries all die and it's no longer resiliency. So I think we're seeing a bit of temporary resiliency from these short-term batteries, but that true resiliency is really going to come out when you can store energy for 12, 24 hours, then that's when you're in a really strong position to be resilient. And even then, like the regulators might open up to the idea of, okay, well, save 4 hours for ancillary services and then do what you want with the rest of it.
Interesting. We are down to sort of the end of our time. I do want to give the audience a chance to ask our panel a question. So if anyone has a question, if we see your hand, actually, I was just going to say, I imagine now I probably have to do the run around here because I think we have all the microphones. Any questions for the panel at this point around demand response or their experience with that kind of thing? Look, I see one back here. Tell you what, I will.
Oh, no, there's a microphone.
Wow, look at that. Excellent.
Question for you, Sarah. Have you guys noticed your demand dropping off with the heat pump conversion of heat?
Yeah, we have actually. So that was something that we did start to notice. I want to say we didn't really start seeing it until about a third of our customers had gone to heat pumps, and we did start seeing a drop in demand in the winter, both in terms of overall energy consumption, but also a reduction in on-peak energy use. And this is kind of, we were talking about this earlier. Heat pumps are a really great energy efficient, sophisticated technology. They do not need human intervention to operate efficiently. And it's actually best to just leave your heat pump alone. It's got inverters, it's got all sorts of compressors, and it can vary its speed and how much energy it needs to draw, and it makes all those decisions by itself. So the best way to let a heat pump operate is to just leave it alone. And if homeowners and customers are given that proper instruction when their heat pump is installed, find the temperature you like and set it and forget it, we actually saw an additional 20% reduction in demand in those homes that just leave their heat pumps alone.
Did you see an increase in summer peak? Because now
We
they have
did, so
AC.
that was something for us that, hey, air conditioning, right? That was a little bit of a lag because we have more weeks of cold in the winter than we do of heat in the summer. But yeah, there's about a week now in the summer that we have a little spike of air conditioning load. Yeah. But the good news there is it's 3 times lower than what it is in the winter. So yeah, we can meet that demand, no problem.
It's a tough one to keep it a constant temperature. I feel like me and my girlfriend are always fighting over the thermostat up and down. Like,
Yeah.
Yeah, there might be a social thing going on there, well beyond just the thermostat, right?
Oh, yeah. And
Whose
we've been-
feet are cold,
Yeah.
and when you want to shower, and all those other things.
Yeah.
So-
And energy behavior comes into that, and we worked with the National Research Council to talk to people about their comfort and heat and that kind of stuff. And yeah, some people are like, I'd like it to be cold in my room at night. I don't want the heat to be at the same temperature. And it was really hilarious because they even got into asking questions of like, what do you sleep in, right? So we say to people like, oh, turn your thermostat down by a degree and put on a sweater. Can we tell them that overnight? Like, how much are we infecting your comfort if you're, if we're telling
I
you
don't know. If my utility calls and asks me what my pajamas are like, I might,
yeah. So we
I might
did
decline
eliminate.
to answer. Just
Yeah.
So we have another question here.
This sounds like it could be an ad for 8 Sleep.
Here we go.
I actually had a follow-on question that was more just around with New Brunswick Power. How does that impact the consumer's price that they're paying? Like if you're decreasing the peak load by 30%,
Yeah,
is
and
there a price? Like is that a way to incentivize them, or is that kind of off the table? Like how's that structured?
No, we do have programs. So we have a program today in market. It's only for our commercial customers at the moment, just because they're the only ones that have enough load to make it worth their while and our while. So we do have, it's called a Peak Saver program, that we pay $60 per kilowatt of reduction in power in the winter. Yeah. And we're looking at similar types of programs we could introduce in residential. Residential, it's probably going to be more around time of use rates, but it could be as simple as we send a text message if you've opted into this that just says, figure out how to reduce your consumption. Our larger consumers, sometimes it's just one thing that they turn up or down, and then they can get 100 kilowatts. Those are the ones we want to go after because it's quick, easy, large amounts. With residential customers, unfortunately, it's turn your thermostat down by a few degrees. There's a health and safety implication there, right? We don't want people to say, well, I'm going to turn my thermostat down to 15 degrees for the next 3 hours because I can get $100 from MA Power. Health Canada will say that 20 degrees Celsius is the safe occupancy level. So we don't want anyone to be putting their health and safety at risk in response to our program. So that's why we have to come up with different types of rates and different types of innovation in how we interact with our customers.
Maybe two quick things there. Is one, 20? Because I'm going to have to go home and turn my thermostat
I know,
up because my
I like
wife-
19. That's
You're
my
telling me
happy
my
place.
wife was correct. Okay. So, but I think I'm going to pick up on this theme because, and maybe just the question, because we have talked a lot about value and, value to a customer. Here, I'll give you, $10 if you do this or $100 if you do that. But of course, there's the bigger value, like infrastructure deferral value, which in theory should help all payers, but it's perhaps a little more diffuse. I don't see that on my bill when, in theory, the utility makes a good decision somewhere else that avoids a spend. But I would potentially see a small increase on my bill because of socialization of those costs. I don't know if that's another component of this value
Yeah, well-
discussion, that it's even more nebulous than the I will pay you for doing something directly. Taking your shower at a different time of the day is an example.
Yeah,
right?
well, that 1 cent rate increase that I just mentioned, that's equivalent to a 10% of our rate increase. And we had been mandated by government to not exceed more than 2% a year for about the last decade. What has inflation been over the last 5 years, right? So we're now trying to play catch up on that, and we just applied for a 9% rate increase that equals 1 cent per kilowatt hour. 9% increase in my bill, like that's a lot for a lot of our customers. So our biggest challenge there is a change in mandate. So instead of us having all of our fossil fuels offline by 2041 was our original plan, that's now been escalated to 2035. And the only way we can get to 2035 and get rid of all the fossil fuels in New Brunswick is to increase rates by 40%. Right.
And I think this goes back to the education piece that was talked about earlier in the day. It's like these upgrades and to the substations, like if we go business as usual, it's going to get very expensive, and that cost is going to get passed on to everybody. So it's not like this might be the cheapest electricity rates we see for the next 20 years, unless we have these innovative technologies to be able to help address this demand.
Yeah, is there a better way to use what we have already, increase the capacity use of it and everything else? Our time is up, so I will ask all of you out there in the audience to help me thank our three panelists. Some great insights into what's going on in demand response.